Good morning, everybody. Today you get to take your notes and listen to me on a video. What we're going to cover today is how to go back and forth between angles and a new unit of measurement called a radian. And radians are important because most trig equations and physics equations actually don't use degree measurement. They use a radian measurement. So it's more universal, and although in our heads a degree measurement makes a lot of sense, uh, in order to apply it, we're going to have to know what a radian is. So we'll learn about this today. Tomorrow, we're going to do some more practice with it and start using some of the first formulas with it. And then we will be down the road. Our next progress check is going to be on Thursday. All right, so your sheet should be in front of you. It should say 6.1, day 1 radian measure. And you'll notice on the front, all I have is just some prompts to you about circumference. And remember what circumference is. Circumference, you'll spend a lot of time using circumference in geometry. It is the perimeter of a circle. And if I asked you for the formula for the circumference of a circle, it is C equals 2 pi r. Or some of you guys might have learned it as C equals pi d. But for our what we're going to show you today, I think I want to stick with this one here. So the circumference of a circle, or the perimeter and measure around the circle, you've always used the formula 2 pi r. All right, the first question I have for you then is, what is the circumference of a circle with a radius of 1? And notice it says keep in terms of pi, which means we want to have a pi in our final answer. So if you make a circle and it has a radius of 1, so from the center out to the side, there's our radius of 1. What I want us to do is talk about the measurement all the way around the circle. So this here is going to be our standard position, our starting point. If we were to go all the way around the circle, what is that total circumference? Well, my radius is 1, so I'm going to go C equals 2 pi times 1, or the circumference all the way around is 2 pi. Now, a couple new things about this is when you see a radius of 1, the name of the circle, it's a special case of a circle. It is called the unit circle. And we're going to be doing a lot of work with the unit circle over the next couple weeks. But this right here, the circumference one time around, is 2 pi. This is a very important fact. In a little bit, we're going to use this fact that all the way around is 2 pi. And you already know that all the way around in degrees is 360 degrees. Okay, second question. What is the circumference of half of a circle with a radius of 1? Okay, so I'm going to draw another circle. Not a very good one, but my radius is 1. And if I talk about starting in standard position, now I only want to go halfway around. So I want to go right there, and then we're going to stop. It's halfway around the circle. So if a full circle is equal to 2 pi, then halfway around the circle is only 1 pi. And this will be something you're going to use so often that it won't be long until, excuse me, that you have that memorized. So 2 pi all the way around, 1 pi is halfway around. Well, let's keep going with that. What is the circumference of a quarter of a circle with a radius of 1? Keep your answer in terms of pi. Here's my circle. Not a good one again. My radius is 1. And this time, rather than going all the way around, I'm only going a quarter of the way. So there's my starting point in standard position, and I want to go right there. So we're starting in standard position and going a quarter of the way. Both the full circle is 2 pi. One quarter of a circle is going to equal 1/4 times your 2 pi, or a half a pi. And what you're going to find is we won't be using the 1 in front of there. What we're going to write it as is pi over 2. Okay, and then finally our last one. Get this out of the way. 3/4 of a circle. So if we start here in our standard position, right there's 3/4 of the way, we're going all the way around. And if our full circle is 2 pi, 3/4 of the circle equals 3/4 of 2 pi, which is 6/4 or 3/2 pi. And again, this is going to be one that you will use so often that you're going to have that memorized. Okay, so flipping it around, or sorry, your note sheet around. What is a radian and how are we going to figure out how to convert back and forth? Well, let's get the definition of a radian down first. The definition of the radian is the angle made by taking the radius and wrapping it along the edge of the circle. So you might want to draw a little picture up on the side, top corner. If you have a circle, and I'll use a unit circle, which means my radius equals 1. What you want to do is think about, all right, that length right there, how long that is. That's 1 unit of measurement. If you were to now wrap that along the edge of the circle the same length, it might be there. So that's also 1. Okay. What your radian is this angle that's formed. Okay. So right there, that's our angle or our radian measure. So try to take a guess of how far you think that is. How many degrees do you think that is? All right, when I look at my picture, I'm like, it's definitely more than 45 degrees. Well, we can figure that out exactly in our calculator. If we take 360 degrees and divide that by 2 pi, and if you throw that in your calculator, make sure you have the 2 pi in parentheses, you should get about 57.29 degrees. So 1 radian is approximately 57 degrees. All right, when we write our conclusions, 360 degrees, we've already said, is equal to 2 pi. That's all the way around. Right below that, halfway around the circle, well, half of 360 is 180, is 1 pi. 90 degrees, which is a quarter of the way around the circle, is pi over 2. And 270, which is 3/4 of the way around the circle, is 3 pi over 2. All right, now when you're doing your conversion, keep in mind the reason why we're going to use these conversions is you have to always keep in mind 360 degrees is equal to 2 pi. So we're going back and forth between these two. If you look at this, I could divide both of these numbers by 2. So 180 degrees is equal to pi. So 1 radian is equal to 180 degrees over pi. So what I want you to write below that, make a star, although mine's not very good. To convert from radians to degrees, multiply by 180 over pi. Okay, 1 degree is equal to pi radians over 180 degrees. So to convert from degrees to radians, multiply by pi over 180. Okay, real quickly, we'll go through a couple examples here. So example A, change 300 degrees to a radian measure. So 300 degrees. Now what I want you to do for now is you're going to look up above and try to decide, should I be using the 180 over pi or the pi over 180? But really, we want to get rid of the word degree and convert it to a pi radian. So in order to get rid of a degree, if you're setting up a proportion, you need a degree down here. So I'm going to be putting my 180 degrees here and my pi up there. And I got that from over here. All right, let me erase that. What I would suggest you do is, I don't want a decimal answer here. So what you want to do is take 300, divide it by 180 in your calculator, and then hit the math fraction button. Or you can just simplify and look at what goes into both 300 and 180. But if you take 300 divided by 180, math fraction, you will end up with 5/3. So 5/3 pi is my final answer. If you go straight below it, now we're going to do 45 degrees to radians. So 45 degrees times, and again, I want to get rid of this degree. Like you can think about, if you look at the problem before, I am actually crossing off my degree measurement. So 45 degrees times pi over 180. My degree measurements will cancel. And 45 divided by 180, if you put that in math fraction, is equal to 1/4 pi, or pi over 4. All right, going the other way. If I have 2/3 pi radians, and when you see a pi, you don't have to write down the word radian. It's implied that the unit of measurement on pi is a radian. So 2/3 pi, if I want to get rid of the pi's and convert it to degrees, I need to have a degree up on top when I'm all done. So I'm going to multiply it by 180 over pi. This time I was using that formula. Well, the nice thing here, the pi's will cancel. You can multiply across and divide by 3, or just simplify them in your head, and you will get 120 degrees. All right, changing pi thirds, or 1/3 of a pi, radians. So this pi over 3 is 1/3 pi, times, well again, now I want degrees in my final answer. So I have to have degrees up here in my numerator. So 180 divided by pi, and these will cancel. 180 divided by 3 is 60 degrees. All right, you have 2 more practice problems. Nope, actually I don't have those on there. So extending the page. E is 150 degrees to radians. So take a minute and try that one. Your final answer you should have got is 5/6 pi. And then finally, F. Change 7/4 pi radians to degrees. Well, if you have 7/4 pi, think about what you need to multiply that by so that you can cancel the pi and end up with degrees in your final answer. Well, if I want degrees in my final answer, I should have 180 degrees on top and pi on the bottom. My pi's will then cancel, and if you take 7/4 times 180, you will get 315 degrees. All right, what I would like you to do now is pause the video and let Mr. Mertens know that you have done taking the notes, that you're done taking the notes, that you need the homework sheet, and I would just want to go through a couple of the homework problems with you together. The first homework problem that I want to do with you is number 1. Number 1, when you look in the instructions, say convert the degree measurement of the angle to radians to the nearest hundredth of a radian. Well, remember that normally we left our answers with a pi in it, but now we're actually going to use pi and finish putting it in the calculator to get a decimal answer. So for number 1, if 31 degrees, and I want to go to a radian measure, you're going to go 31 degrees times pi over 180, because that's how we are going to cancel our degrees, and then throw that straight in your calculator. 31 times pi, divide that by 180, and it's said to round to the nearest hundredth, so we get 0.53 radians. So you should be able to finish off the rest of that first section. Number 7 says convert the degree measure to an exact radian measure. Well, circle the word exact. That means I don't want you to do any rounding. So your answer should probably still have a pi in it. So if we're going to start with 35 degrees, we're going to do exactly like we did above. Take 35 degrees times pi over 180. Our degree measures will cancel. And this time you're only simplifying the fraction 35 divided by 180. So take 35 divided by 180 in your calculator, hit math fraction, and you will get 7 pi over 36. And the fact that you see that pi there tells you it's a radian measure. All right, you should be able to finish that section off. Number 11, first one in the next section, says convert the radian measure. So that 1.4 is radians, which tells you it's like number 1, the pi is in there. So we have to get rid of the pi that's in there when we convert it to degrees. So we're going to take 1.4 radians we want to convert to degrees. So you better have your degree on top, so 180 degrees over pi, and you type that exactly as is into your calculator. 1.4 times 180, divide that by pi, and it says to round to the nearest hundredth, so 80.21 degrees. And finally, number 15. Convert the radian measure to an exact degree measurement. Now this is like what we did on our notes. Pi over 3 is our first one, and I want you to convert that to a degree measurement. So pi over 3 times, now I want degrees, so we have to have degrees in our numerator, over pi. The nice thing here, the pi's will cancel. 180 divided by 3 is 60 degrees. Okay, you now have enough information to get you or you should be able to finish up the homework. So finish up the front page, and then on the back you'll notice we have some practice with degrees, minutes, and seconds from last week, and you should be able to get those finished off. If you have any questions, Mr. Mertens does have my answer key for the homework, and he could definitely help you with working your way through these problems. So with the remaining time, you should be able to have enough time to get your homework finished. I will see you guys all tomorrow. Good luck. Hope you're having a great day.